In this video, we'll continue the line following car tutorial. In this particular video, I'll show you how to use the vision sensors. So we'll continue from the previous tutorial where I showed how to do speed control of the car. That particular file is in the description. You can download it and follow along. So in this class, we'll be using the function called read vision sensor, which reads the data from the vision sensors. Those sensors are shown here. There are 3 of them. I'll show you how to understand the outputs from the vision sensor, which will be useful when we do the line following. And finally, I'll show you how to associate floating views, which are shown here, so that you can see what actually the sensors are seeing. Okay, so this is the code I developed in the previous tutorial. If you run this, you'll see that the line following robot goes straight. Let me rotate the view. Okay, and now we can actually see the sensor. So when I click on the left sensor is shown here, and I click on the right sensor is shown. There's another sensor, the middle sensor. We will not use that in this tutorial. Okay, so the next step is to actually read the data from the left sensor. That we go to the regular API and go search for read vision sensor. So for the vision sensor, the Lua function is something like this. Read vision sensor, I need the handle of the vision sensor, which I need to create. And once I have that, it'll output at least two outputs. One will be the result, and the other will be aux value packet 1 and so on. So let's copy this. Go to the code. And since it's part of the sensing code, I'm going to drop it here. So in this case, I'm going to ignore, I'm going to ignore the, we really could do consider the first 2 arguments, not the remaining outputs. So just let's call that data left, assuming this is the data from the left sensor. And then I need to create a handle. Yes, so let's call the handle left sensor, but this has not been defined. I need to define that main it. So I'll go here and copy this, and then left sensor, and then I need to call it the same name as it's here, left sensor with LNS capital. Right sensor. Okay, let's just run this, see if this code works fine. Looks fine. Okay, now that we have got this code in place, let's try to understand the outputs. Okay, so the first one is a detection state. The second one is an auxiliary value packet. It has 15 values. These 15 values are going to be, says the minimum of intensity, red, green, blue, depth value. So those are 5 numbers. The maximum of the intensity, red, green, blue, and depth values, another 5, so 10, and then finally average. So there are 15 values which consist of the minimum, maximum, and average of these 5 things. So let's just see what that values are. So what you can do here is you can actually make it print the data. So I'm going to make it print, and I'm going to just copy some code I done earlier just to save time. So it's this. Okay, so now what I'm doing here is I'm printing the minimum intensity, RGB, and depth. That, as I said, is in the data left has 15 variables. So first, second, third, fourth, fifth. The maximum intensity, RGB, and depth, that would be 6, 7, 8, 9, 10, and then finally the average intensity. Okay, just to make this printing look good, I'm just going to make a new line. And now let's just run this. Okay. There was an error. Sensor. Okay, so what happened was that the data value returned was nil, and that's why it wouldn't print. So the issue was this: it was data left, not date left. We shouldn't need this. And keep that one. So let's run this. So you can see it's printing these values. Okay, let me stop. So you can see that the minimum intensity is about the same with the maximum and average. Same for RGB, they're almost the same. So we can just use any of them for our control purposes. Let's just use the average. Okay, so I'm going to just use the print average value. Now let's do the same thing with the right sensor. Okay, and then just ignore this. And I did that ahead of time. Okay, so let's say this is the left, the right, and let's play this. Okay, pause. So you can see that the values are about the same. Okay, so just to really convince you that these values are reading something meaningful, I'm just going to create a plane and put it over here so that we can see the effect of how that vision sensor will detect those differently. So I'm going to say add primitive shape plane. I'm going to choose this to be 0.5 along the x-axis and then 0.2 along the y-axis. And then we're going to move this plane right here so that the left sensor sees it, but the right sensor does not see the plane. Pause. Now you can see that the left sensor is actually reading 1, 1, 1, 1. That just means that the color of the thing it is seeing is white. And then the right one doesn't see the white plane. Okay, let me just move this down. Stop this. Now, sometimes you want to see what the camera is actually seeing. So what we can do is we can right click and say add floating view and keep it on the left. Okay. Next, I'm going to associate this view with the left sensor. So I click on left sensor, then I right click on the floating view and say add, view, associate view with selected vision sensor. So now what you see here is what exactly the sensor is. We can do the same thing with the right sensor. So right click, say add floating view, click on right sensor, right click on floating view and say associate view with selected vision sensor. Okay, so now when we run this, you'll see that the left sensor is seeing white, the right sensor is not. But as the car goes beyond the plane, you'll see that both of them see. Okay, so the last thing we'll do is we'll change the color of this to red. play this. So I see one of them seeing red. In fact, if you see here, you'll see that's 1.09, almost 100, which means it's red, and the other sensor is not seeing red. And you can see the intensities are different, 0.39, 0.75. So you can use either the intensity or this RGB values to distinguish between um, colors, red versus the floor. And then as you see in the floating view, right now the left sensor is seeing red, right sensor is not. And then once it goes past, both of them see the floor. That's how you interpret the vision sensor.